hyperbola with center at origin. So we want here to prove this slant asymptote y is equal with a b over ax and y is equal with a minus b over a times x. So first of all, to prove this, let's take this equation here. So let me take a pen. And we have a x squared over a squared minus a y squared over b squared is equal with 1. So we are going from this equation. And now we are solving this equation for y because our purpose is to find these two equations. And now if we are putting the y squared over b squared in the other side, x squared over a squared is going to be 1 plus y squared over b squared. So I'm taking some shortcuts here. And now I am moving the 1 in the other side, but the y squared over b squared, so the right side, just I am switching the sides, and this one I am putting in the other side, but in the other side x squared is over a squared, and the plus 1 is the change in the sign when I put in the other side become minus 1. And everything here I am multiplying by b squared. If I multiply everything by b squared, and here in this side of the b squared is going to simplify because y squared b squared divided by b squared, it remains just a y squared. But in the other hand, on the other side, here is going b squared over I squared. So because I am multiplying the first term, x squared over a squared, so I'm just rearranging a little bit this. And 1 times b squared is b squared. So we are in this situation. But now we want here to factorize b squared over b squared times x squared over a squared. If we are factorizing this, then this is going to be b squared x squared over a squared, which is 1 minus, but here I have a b squared. So b squared I already have here, and to factorize this is going to be a squared over x squared. So this is going to be, because if I multiply everything by 1, I get this value, and if I multiply b squared x squared a squared times a squared x squared, I'm going to get a b squared. So I am in this situation. But now, because we have to solve for y, let's take a square root both sides. If we are taking square root both sides, y is going to be equal to the plus minus everything here in the square. b squared x squared over a squared times 1 minus a squared over x squared. So that's what we get. But because everything here is a square, we can release it from the square root, and y is going to get a plus minus b times x over a, and everything here remains just this part, 1 minus a squared over x squared. But now, because we are looking here to find y, and because we are looking here to find the asymptote, to get something in this form, we want to know, first of all, we want to know, because the asymptote describes the behavior of the function, the end behavior of the function. So we are going to look how it's going to look at this function, how it's going to behave to infinity. And first of all, let's say if y is equal to 0, so this is going here to be minus a, and this here is going to be a, because if y is equal to 0, so x here, we are looking what is going to be the x, so this is going to disappear. Imagine this does not exist, so x squared over x squared is equal to 1, so x is going to be plus minus a, so that's what's going to be a. And a, as we see here, is a real number, defined number. But now we want to know how it's going to behave this function to the end behavior, and we are taking just this part here. So just let me make a little room. Let me write it with a different color. If we are taking limit as x approaches to infinity, and we are taking just this part here, just this part, a squared over x squared, and a is element of real number, is a defined number, but if we are applying here a square over infinity square, this is going to be equal with 0. As x approaches to infinity, so a squared over x squared, so as x approaches to infinity, a squared over x squared approaches 0, goes to 0. So now this value y is going to be approximately plus minus bx over a, b time x over a, time just 1 here, square root of 1. But square root of 1 is 1, so y is approximately plus minus b over a times x. But because we are looking here asymptotes, and asymptotes here, so as asymptotes, so just let me write, is going to be equal with a b over a times x, and the other asymptote is going to be minus b over a times x, which already we proved. So just let me go up a little bit. We already proved that this is a y is equal to b over a x of the slant asymptotes here, and the other slant asymptote is y is equal to the minus b over a x. So we already proved those asymptotes.